So, lesson 7-6 notes, we're going to be solving rational equations. So, in the last few lessons, we've been doing a lot of graphing, but today we're going to go back to solving. So we're going to put our skills that we used with expressions into dealing with equations. Now, what's the difference between an expression and an equation? Good, there's an equal sign, good. So these are going to have equal signs, but we do a lot of the same rules with these. Yes. Here, So here are the steps to solving rational equations. So they contain one or more rational expression. When solving rational equations, you need to identify the restrictions, so basically where the denominator is 0. So ultimately, this is your step 1, but the first thing you want to do before you even do that is to have it fully factored first. Then identify values where the denominator is 0, multiply each expression by the LCD to eliminate all fractions, and then basically you're just solving an algebraic equation. Yes? Okay. And then you're going to eliminate any extraneous solutions which correspond to the restrictions found in step 1. So you'll see what I mean by all of that as we do our example. So we look at this first example, and the first thing I want you to think about is this factored or does it need factoring? What do you think? Does it need any factoring? No, it's fully factored, so we can skip the factoring step. Next thing you want to look at is these denominators. Oh, you're right. It does need factoring. I don't know what I'm talking about. Whoever said that right was correct. So, yes, it does need factoring. Thank you for that. I got distracted there for a second. So, the denominator is the difference of squares. So, what is the denominator going to factor into? Good, x minus 1 and x plus 1. Now, once we factored it, we're going to identify the restrictions. So, what x value could not be here because it would give me a 0 denominator? Good, it can't be -1. And what x value could not be here that would give me a 0?
Positive.
Good, +1. So your restrictions, you can write them as x cannot be 1 or -1, or you can write x cannot be plus or minus 1. So either one is fine. So notice that this denominator has the same restrictions, so we don't have to write them again. Hello? So from here, what you're going to do is you're going to identify your LCD. Okay, what does LCD stand for? Good. So the way we identify our least common denominator is to look at these as each separate factors. Okay, so the x plus 1. Do any of the other denominators have it? Yeah, it occurs twice, but you only need to write it once. So anything that occurs more than once, you only need to write once in the LCD. And then what's another independent factor in the denominator? Good, and it also occurs here, but you only need to write it once. So once you've found all of the possible factors of the denominator, this is your LCD. Now once you've identified your LCD, the goal is to then multiply all of the numerators of the fraction by that LCD. Now when I say do that, you're just going to write it out. You're not going to actually go ahead and distribute and all of that, because things are going to cancel out. So if you multiply properly by the right LCD, the denominators will go away completely. That's the goal. So I'm going to take my first numerator, and I'm multiplying it by the LCD. So you're just going to write it as a product, but you're not going to actually multiply it out yet. And you'll see why, because we want to cancel stuff out. I'm going to take my second numerator, and multiply it by the LCD. And then I'm going to take my last numerator and also multiply it by the LCD. Now once you've done all of that, as long as you've identified your restrictions, you can now start canceling things out. So what do you notice is going to cancel out of this first fraction? Good. The second one? Good. And what about the last one? Both of them cancel. So you're going to rewrite what is left. So it's just x times x minus 1 plus x times x plus 1 is equal to 2. So the reason you don't want to multiply it before you cancel is because now it's going to be a lot easier of a problem. So now at this stage, you're going to go ahead and simplify this. So we are going to distribute on both of these. And that's going to become x squared minus x plus x squared plus x is equal to 2. And what's going to happen with those two x's? Good. And what's going to happen with x squared plus x squared? Good. And then what's going to happen? Divide by 2 on both sides, which gives me x squared is equal to 1. So does everybody see how I got to x squared equals 1? Now how would I solve that from here? Square root both sides, which will give me x equals plus or minus 1. Now before you write it in the solutions box, don't write it there yet, because we have to see if this solution is rejected. Anybody think, what do you think, is this solution going to be rejected? Think about it for a second. Why would it be rejected? Good, because of its restrictions. So if any of your solutions or all of your solutions come out to be what the restrictions are, this is rejected and called a what? Extraneous. Good. So this is what we call extraneous. So that's an extraneous solution. Good job. So now what I'm going to do is I'm going to show you how you can use Desmos to check your work. Now, just before we get into this, this is a disclaimer. This is only helpful to check your work. It's not a replacement for the algebra, all right? So I'm going to show you how we would use it to check our work. And you can do this also on a test or whatever you want. So how you go about doing this is you go to Desmos, and you type in, what is that? You type in one side of the equation as one of the functions, and then you type in the other side of the equation as the function in Desmos. So basically both sides, okay? So what's going to happen is these two graphs are never going to intersect. And why would these two graphs not intersect? You want to change your chair out?
Yeah, that's what I was going to do.
Okay. So why would these two graphs never intersect? Because they don't have any. You're on the right track. They don't have a solution, right? So do you remember back to the days when you learned about linear equations, and if they're parallel, they never intersect, meaning they don't have any solution? A graph is a physical representation of where they have the same solution, okay, where they intersect. So you can use Desmos to check that, and when we have one that does have a solution, you'll get to see what that looks like as well, okay? So Desmos will show you these do not intersect, which means they have no solutions. So now we're going to move on to example 2. First thing we do is look at it and see if it needs factoring. What do you think? No, it doesn't need any factoring. So then we're going to see if we can identify the restrictions. So what do you think here? Are there any restrictions? Good. X cannot be 0 because that will give me a 0 in 2 of my denominators, which is bad. Now we're going to identify the LCD. So does anybody have an idea what the LCD is here? Good. It is 4x. So does anybody need more information on why the LCD is 4x? Everybody feel good about why it is 4x? Yeah. Yeah, sure. So the reason it's 4x is because notice that 2 of these denominators have a 4, and 2 of the denominators have an x. So whatever they have, they need to have in the LCD, and you only need to write it once if it occurs multiple times. So now that you've identified the LCD, you're going to multiply all of your numerators by that LCD. So 1 times 4x is just 4x over 4x. And then I'm just going to leave this in parentheses. You'll see why, but it's not necessary. If you did multiply it, it still will come out to be the same answer. And then 7 times 4x all over x. So I just multiplied all of my numerators by 4x. Now once you do that, you're going to see what's going to cancel out. So, looking at our first fraction, what is 4x divided by 4x? Very good. It is 1. And then what's going to cancel out in this fraction right here? The 4's, which ultimately leaves me with what? Good. Minus 3x is equal to, what cancels out in this one? Good. Which is going to leave me with? Good. Now this is kind of just a side note, but I saw a few people getting confused about this today. If I have something like this, m minus 3 over m, can I cancel out the m's? No. You can only do it when it's multiplication. So just be careful when you're doing these. This was right, but I just wanted to make sure you knew that. So, how would I solve this from here? Good. Subtract 1 on both sides, which leaves me with negative 3x is equal to 27. And then we solve that by dividing, which gives me negative 9 as my x. Now, will this solution be rejected? No, why not? Good. It's not in the restrictions, which is what we want it to not be. So, everybody have this down. I'm going to move the Desmo screen over. Okay. So what I'm going to do on Desmos is I'm going to type this into check. So 1 divided by 4x minus 3 divided by 4. So that's the left side of the equation. Enter. Then I'm going to do the right side of my equation. 7 divided by x. Now when you do this, these should intersect at what point? Negative 9. And do the two graphs intersect at negative 9? Yes, they do, which is what we expected. So, use Desmos to check your work, and it will help you. And if you went to their tables, you could also see that their tables would match at negative 9 as well. So, see, they have the same y value. Okay, so that's how you check your work using Desmos. So is everybody ready to try example 3? Alright, let's try example 3. So the first thing we want to do is factor if possible. Now can this one be factored? Yes, we can factor that denominator right here, and that factors into what? Good. This factors into x plus 2 and x plus 1 plus 2x over x plus 2 equals x minus 1 over x plus 1. So that's what we end up with at this stage. Yes?
But why is the first one the way that it is?
Gosh, you mean how did we get from this to this?
Yeah.
We factored it. So if you remember back to when we learned about factoring trinomials, you look for factors of this term right here, the 2, that add up to 3, and that will be the 2 binomials that Does that make sense? Okay. So this is where we're at so far. Now we're going to identify our restrictions. So what x value will give me a 0 in my denominator? Negative 2, and also what else would be bad? Good. Negative 2 and negative 1 would both give me a 0 in at least one denominator. So, now that we've done that, we can identify the LCD. So if we look at our first factor of our first denominator right here, what other denominator has that one? Good. So that one is going to be included once. If it happens more than once, you only need to still include it once. Same thing here. These have the same factor. I only need to include it once if it occurs twice. And that would be my LCD. Now once you've identified the LCD, you're going to write it by multiplying it by all of the numerators. But don't actually go ahead and multiply it, just write it next to it. You'll see why. You never want to multiply yet because things will cancel out. Now, I don't know if anybody's starting to see the pattern, but notice the denominators always go away. and that's because we're canceling out, right? So once you start getting more familiar with this process and you get comfortable with it, you don't have to write this intermediate step out anymore. You know what I mean? If you know it's going to cancel out, you can kind of skip it. So just keep in mind, these problems always seem longer when you first start learning them because you're doing every tedious little step that you wouldn't do once you really were familiar with the process. Alright, so we are at this stage. What I like to do at this point, just because there's so many different steps, is I just go through and check and make sure I did it all correctly and didn't make any mistakes before I start canceling. And now at this stage, I'm ready to cancel. So what's going to cancel out of this first fraction? Good, x plus 2 and x plus 1, which is just going to leave me with x minus 1. And what's going to cancel out in this one here? Good. It's going to be plus 2x times x plus 1, which is equal to, what about this one? Good. Yeah, just this one. Yeah. Yeah, okay, just making sure. Okay. So then it's just going to be this. And then from here, we're going to need to simplify this. So the way we're going to have to do that is we're going to distribute here, and over here we're going to FOIL. So this is going to leave me with x minus 1 plus 2x squared plus 2x is equal to, distribute, x squared plus 2x minus x minus 2. So everybody with me at this stage, what we did. Now you're going to combine like terms on each side. So on this side here, I'm going to combine like terms. And while I do that, I'm also going to move it into standard form. So I'm going to put the highest degree term first. What is x plus 2x? Good. 3x. And then we have that minus 1 equals x squared. What's 2x minus x? Plus x minus 2. Now, what we're going to do here is I see that it's quadratic. And that means I want to get everything to one side to factor it. So you can do this in multiple steps, but I usually just do it in one. I'm going to subtract everything over or add whatever operation is necessary to get everything to one side of my equation. So I'm subtracting over the x squared, subtracting over the x, and adding over the 2, which is going to cancel these all out and leave me with 0 on the other side. So then we just simplify. So what is 2x squared minus x squared? Good. Next one is going to be, and lastly it's going to be plus 1 is equal to, all of these went away, so this is just 0. And then from here, this should factor nicely into two binomials, which are, good, x plus 1 and x plus 1. Now you're going to set each of those equal to 0, and when I do that, I get the same answer for both, which is negative 1. Why did I put a not? Well, it is going to be a not, but I don't want to say that yet. So this is going to be x equals negative 1. Now, what's the issue with this solution? Good, it is the restriction, so this is extraneous. So there is no solution. Meaning if you were to graph these would not intersect. No solution. So does anybody have any questions about that? Alright, we're going to do number 4 and then we'll take a 5-minute break before we go into the second part. So, number 4. First thing you're going to do is see what we can factor out of this. So I'm just going to erase this so you don't see it and get confused. The first one does not factor. And this part's tricky, but this numerator actually doesn't factor. I know it seems like it's going to, but there are no factors of negative 10 that add up to a negative 1. So therefore we just leave it. But the denominator will factor, right? And what will the denominator factor into? Good, x plus 3 and x plus 5 is equal to 3 over x plus 3. So, from here, we are going to identify the restrictions. So what do you think are the restrictions here? Good. X cannot be -3 and x cannot be -5 because those are two values that would give me a 0 in my denominator, in at least one denominator. So then from here, we're going to identify our LCD. And are you starting to get the hang of what the LCD is here? What do you think? Good, x plus 3 and x plus 5, because those are the two factors that comprise of all of the denominators. It doesn't matter because it's commutative. Yep, good question. So then from here, we're going to multiply all of our numerators by the LCD.
You don't have to write that out.
If you know how to do it and you feel good about it, no, you don't have to. If you know what's going to cancel out, yeah. So yeah, once you get comfortable with that process, you don't have to write this all out as long as you know what you're doing. It's one of those things that's just going to click at one point and you'll be able to figure it out. I think I did everything right. I just double check. I multiplied everything by x plus 3, x plus 5, and now we're ready to cancel out. So in this one, the x plus 5s are going to cancel out. This one, the x plus 3s and the x plus 5s. And in this one, the x plus 3. You know you've done it correctly if your denominators are gone, which they are. And now you rewrite what is left, which is 2x times x plus 3. Now this is where you have to be careful. What's going to happen here because it's a minus? Good. It's going to make all of the signs of those change. So it's going to be minus x squared plus x plus 10, which is going to be equal to 3 times x plus 5. And then from here, you're going to use the distributive property. We get 2x squared plus 6x minus x squared plus x plus 10 is equal to 3x plus 15. And then combine like terms on the left, yeah. So that's going to be 2x squared minus x is x squared. 6x plus x is 7x plus 10 is equal to 3x plus 15. And then subtract everything over to one side of the equation, which leaves me with x squared plus 4x minus 5 equals 0. And then the last step is to factor this into two binomials. So what are factors of -5 that add up to a +4? Good, +5 and -1, which give me two answers, x equals -5 and x equals +1. Two tentative answers. Now, looking at these two answers, which one of these is going to be a true answer? Good. And why not the other one? Good. So this one is extraneous due to its restriction. It's an E. But this one is a true solution. So that being said, I'm going to do this one in Desmos because this one actually looks really cool. And you can see what's happening here. So it's not too fun to type in this one, but yeah, we'll do it. I don't know what's happening here. And then minus x squared minus x minus 10 divided by x squared plus 8x plus 15. Enter. And then 3 divided by x plus 3. I got my caps lock on this one. Okay. So I'm going to zoom out on this graph and show you what it looks like. So when I put both of these pieces in, I put the one side of the equal sign, the other side. As you can see, these graphs are pretty interesting, but they do intersect, as you can see right here at 1, which is what we expected, right? And you could also see that they have a restriction at, where did we find the restriction at 5? Negative 5. Yep, so if you go here, you'll see they have a restriction. If you were to type in negative 5, it would say undefined. If you were to type in negative 3, it would also say undefined on both. So any questions about it? Okay, started. Alright, so continuing with our lesson, we're going to be picking back up at example 5. And it says here we're going to solve m equals 2e over v squared for e. So there's two different ways that you approach dealing with, these are what we call literal equations. And literal equations are basically just equations that have a bunch of letters in them, okay, not just numbers. And you're going to be solving in terms of another variable. So if you have just two things on opposite sides of the equal sign, and you don't have something set up like this with a minus, is somebody knocking? You got it. So if this is the case where you just have something is equal to something and you don't have any plus or minus another fraction, what you can actually do is you can take that one letter or number on the other side and just put it over 1, okay? We just started, so you're just going to put that letter over 1. And from here, you can either cross multiply or multiply both sides by v squared. It's going to come out to be the same. So once we do that, we're just going to cross multiply here. And that's going to leave me with m v squared is equal to 2e. And then how would we solve for e in the end here? Good. Divide both sides by 2, which is going to leave me with e is equal to mv squared over 2. And that's it. So any questions about that one? Okay. So let's try the next one. Now this one's a little bit different because we have something in the denominator. So we have something minus something, basically a fraction minus another fraction. So two ways to approach this one. You could find a common denominator, or you can add the other fraction to the other side. And that leaves me with c over e is equal to 1 over mc. So I just added the other fraction to the other side. Now I can cross multiply, because the only time you can cross multiply is when you have an equal sign between two fractions. So cross multiply, and that leaves me with e is equal to mc squared. And that's a legitimate formula, so. So yeah, that's what it comes out to be. E equals mc squared. So any questions about that one? Alright. Next one, example 7. We have two example 7s. Really, it's example 8, but here we're solving for b. We have an equal sign between two fractions. We're just going to cross multiply. That leaves me with q v squared r squared is equal to 2mv. Now keep in mind, you can also have like vm and mv, it's the same thing. And then I want to solve for b. So I need to get everything that's not b to the other side. This is multiplication. So I'm going to divide both sides by qr squared to get rid of this to get b by itself. Which will leave me with b squared is equal to all of this But I'm not done because they didn't say solve for b squared, they said solve for b. So what do I need to do then? Good, square root both sides, which is going to leave me with b is equal to plus or minus. Now, you can't take the square root of this whole thing, but which one of these terms you can take the square root of? Yeah, part of the denominator, right? So this would be 1 over r, because the square root of r squared is r, times the big square root of, this is like a big square root. I didn't do a good job at drawing it, but. And then whatever was left that you couldn't take the square root of, which was 2 Vm over q. So any questions about that one? All right. You ready for the last one?
Wait, where'd you get the 1 above the r?
It's because the r is in the denominator. So in reality, it's not really r. It would be r to the negative 1 power. So I just prefer to write it as 1 over r. Does that make sense? So then this one here, we're solving for little m. So I'm going to put this over 1 so that I can cross multiply. So it's a little weird when they use the same variable but capital, so just be careful. That's my warning, because they're not the same. That's going to leave me with little mv is equal to v times little m plus big M. And our goal is to solve for little m, so I'm going to distribute. I'm going to get mv is equal to mv plus big MV. And then I'm going to try to get, what can we do here? Yeah, we could divide everything by v, yeah. And that leaves me with m is equal to m plus m. Yeah, look at, it goes away, yeah. It's just big M is equal to 0, but it goes away. Yeah, everything goes away on that one. See, make sure what this has. Did I make a mistake somewhere here? They are different. Oh my gosh, you're right. I can't believe I forgot about that.